Hello, this is Trigonometry and Applications One Shot Last Minute Revision. This is Prashant sir recording live for Vidyanti.com. Today we are going to see a little bit about the trigonometric basic concepts and some identities, and then we are going to solve some examples. So let's begin. This is chapter 8. Once we complete this, we will go to chapter 9. Both chapters are covered. So let's start the basic understanding of trigonometry. In a right angle triangle, we have the longest side as hypotenuse, and depending upon which angle you are considering, this is the opposite side and this is the adjacent side. So now we have a ratio of any two sides taken out of these three. So there are three possible ratios. The first one is sine, which is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and the third one is tan, which is opposite over adjacent. Once we understand these three basic trigonometric ratios, then we have three reciprocal ratios. One is cosec, which is 1 over sine theta, sec is 1 over cos theta, and then cot is 1 over tan theta. So altogether we have three basic ratios and three reciprocal or inverse ratios, 1 upon ratios. So altogether we have 6 ratios. One of the things we should remember is many people by mistake they think that cosec is 1 over cos. That's wrong. It's actually opposite. Cosec, even though it has cos in it, it's actually 1 over sine, and sec, it does not have anything related to cos, so that is 1 over cosine. So having said that, let's see some basic identities. Sine square theta and cos square theta, if they add it together, they will become 1. 1 plus tan square theta is sec square theta, and 1 plus cot square theta is cosec square theta. Then we have trigonometric ratios of basic angles between 0 and 90 degrees. So we have 0 degree, 30 degrees, 45, 60 and 90 degrees. And let us first concentrate only on sine, cosine and tan. The best way to remember this is whatever we have on this side, this 45 degree line serves as a mirror line. We have reflection on the other side for other trigonometric ratios. So what does that mean? If we have sine 0 is 0, then we have cosine 90 exactly same as 0, and we have sine 90 as 1, then we have cosine 0 as 1. So as you can see, this middle line, 45 degree line, serves as a reflection line, and then we see the mirror image on the other side. So here we have root 3 by 2, which is sine 60, and that will be exactly identical to cosine 30. And we can repeat that process, sine 30, which is half, and that will be exactly identical to cosine 60, which is 1 by 2. Tan, on the other hand, is a ratio of sine over cosine. So once you know sine and cosine, you simply have to take the ratio of it. So for example, sine 0 is 0, cosine 0 is 1, 0 over 1, that will be simply 0. 1 by 2 divided by root 3 by 2, this divided by 2 will get cancelled, and you will have 1 divided by root 3, which is exactly same as tan 30. In case of 45 degrees, we have very unique situation. Sine and cosine both are identical, so that's why we will have their ratio exactly as 1. And similarly, tan 60, which will be now here by 2 will get cancelled, and it will have root 3. And 1 divided by 0 will be simply infinity. So now this will be the middle line. Sine theta always lies under 1, which is same as cosine theta, and because of that sec theta will be always greater than. Remember, sec theta is reciprocal of sine theta. Similarly, cosec theta is actually reciprocal of cos theta. Sorry, cosec theta is reciprocal of sine theta. It should be other way around. And since these two ratios are lower than 1, these two ratios will be always higher than 1. There is no restriction for tan theta. Tan theta can be from 0 to infinity anywhere. So let's begin with the first question, exercise 8.1, which is question 811. In ABC right angle at B, AB equal to 24 centimeter, BC equal to 7 centimeter, we have to find out sine and cosine of angle A. Similarly, sine and cosine of angle C. So let's construct the triangle really quick. Remember, they have given us that the right angle is at B. So that means AC will be the hypotenuse. the longest side will be directly opposite to 90-degree angle, and this is given as, well, AC has not been given, AB has been given as 24 and BC has been given as 7. So first we will use Pythagoras theorem and calculate the hypotenuse, which is under root 7 square plus 24 square, that will come out to be 25. And once we have all the three sides, then we can calculate any trigonometric ratios for any angle. So let's begin. Here first let us consider sine A. For A, well, for everybody hypotenuse is always same, irrespective of the angle, irrespective of what we are considering. Hypotenuse is always the longest side opposite to the 90-degree angle. For A, BC will be opposite and AB will be adjacent. So now let us consider sine A. Sine A defined as opposite over hypotenuse, so that will be 7 over 25 because opposite is 7, hypotenuse is 25. Similarly, cosine will be adjacent over hypotenuse, that will be 24 over 25. Now let's repeat this process for other angle, which is C. Now if you consider C, for C, AB will be opposite, hypotenuse is always same, and BC will be adjacent. So let's repeat that process. Sine C will be opposite over hypotenuse, and that would be 24 over 25. And cosine C will be adjacent over hypotenuse, that will be 7 over 25. So these will be your final answers. In figure 8.13, find tan P minus cot R. Let's see what is the given figure. We have been given PQR as a right angle triangle, right angled at Q. So that means PR will be hypotenuse. We have been given PQ as 12, PR as 13. Remember, in right angle triangle, any two sides are sufficient to find out the third side. Here we can use the Pythagoras theorem and find out the non-hypotenuse side as subtraction of squares and then taken square root. So this will be 13 square minus 12 square under square root. So that will come out to be 169 minus 144 and then everything under square root, that will come out to be 5. It will be a nice idea if you remember the squares of first 30 natural numbers. You still have some time. If you remember up to 30, then it will be useful for you to calculate these things and identify whether a given triangle is right angled triangle or not. So once we know all three sides, then any trigonometric ratio can be easily found out. First we will find out tan P. The definition of tan trigonometric ratio, tangent is opposite over adjacent. So that will be for P, opposite is QR, adjacent is PQ. So tan P will be opposite over adjacent. That will come out to be 5 by 12. Now cot R will be, now for R, hypotenuse is always 13, there is no question about it, but opposite will be now 12 and adjacent will be 5. So cot is actually 1 over tan, that's adjacent over opposite, so that will come out to be 12 over 5. Tan will come out to be 12 over 5, and then cot will be reciprocal of that, which is 5 over 12. So once you do tan P minus cot R, that will be exactly 0. That will be your final answer. Let's see the next question. If sine A, well, here we have been given one trigonometric ratio. With the help of that, can we identify the remaining two trigonometric ratio? Let's see. This involves construction of a triangle such that the first trigonometric ratio is satisfying that condition. So let's see what does that mean. Since sine is opposite over adjacent, so this will be opposite is 3, adjacent, sorry, hypotenuse is 4. Sine is opposite over hypotenuse. So if we construct a triangle such that angle C has opposite equal to 3 and opposite should be equal to 3, okay, and hypotenuse should be equal to 4. So that means adjacent, which is the third remaining side, the missing side, using Pythagoras theorem we will evaluate it as root 7. Now we have all three sides and we can calculate any trigonometric ratio. So in this case cosine A will be adjacent over hypotenuse, so that will be root 7 by 4, and tan will be opposite over adjacent, that's 3 divided by root 7. So moral of the story is, if you have been given one trigonometric ratio, construct a right angle triangle such that it satisfies the given two conditions. Once we know two sides, well, the third missing side can be easily found out using Pythagoras theorem. Once we know all three sides, any of the three original trigonometric ratios or any of the three reciprocal trigonometric ratios can be evaluated very easily. So there should not be any doubt about it. I strongly recommend you to create different triangles, take random values and check whether you have understood that process. Let's see the next question. 15 cot A is 8, and then we are supposed to find out sine and sec. Well, first we'll understand what is the cot. Cot is 1 over tan, which is tan itself is opposite over adjacent, so that means cot will be adjacent over opposite. So that means, let's say, first let's create a triangle ABC. We are considering side angle A, and 15 cot A for this particular one. AC is the hypotenuse, CB is opposite, and AB is adjacent. So now 15 cot A is 8, so we can take 15 on the other side. Cot A will be 8 over 15, and tan A will be reciprocal of that, which is exactly, you have to flip, exchange, interchange numerator with denominator. So 15 will go as in the numerator, 8 will come out as the denominator, and tan A will be 1 over cot A, which is 15 over 8. So now we have to construct a triangle such that this is opposite and this is adjacent. So opposite is 15, so now this will be 15, adjacent is 8, so this will be 8. Now, using Pythagoras theorem, we can easily calculate the third side, which is hypotenuse. That would come out to be under square root 8 square plus 15 square, and that would be 17. Again, how do I know that? 15 square is 225, 8 square is 64, their addition will be 289, and under root 289, which is 17. For the same purpose, I am recommending you to remember the squares of first 30 natural numbers. Now we can easily calculate any of the trigonometric ratio. Now sine A has been asked. Sine A is opposite over hypotenuse. For A, opposite is 15, hypotenuse is 17, so we will get sine A as 15 over 17. And sec, first we will calculate the cosine, and then we will take the reciprocal of that. So that will come out to be cosine A is adjacent over hypotenuse. So that will come out to be 8 divided by 17, and we will simply flip numerator with denominator, and sec, which is the reciprocal of cosine, 1 over cos, and that will come out to be 17 by 8. That would be your final answer. Let's go to the next question. Given sec theta is 13 by 12. Again, they can give you one of the original ratios or they can give you one of the reciprocal ratio. It doesn't matter as long as you construct a right angled triangle satisfying these two conditions. So now sec is, well, first let's create a triangle. We have ABC. Now let's consider any angle theta. So sine theta is, let's say sine goes with cosec. It's a reciprocal. These two are reciprocal of each other. Cosine is reciprocal of sec, and tan and cot, they are reciprocal of each other. So now we have cosine theta, which goes with sec theta. Now sec theta is 13 over 12. So that means now if sec theta is 13 over 12, that means cosine theta will be exactly opposite of that, 12 over 13. Now cosine is nothing but adjacent over hypotenuse. So now we have to give a sine adjacent to 12 and hypotenuse to 13. So in this particular triangle, as far as theta is considered, let's consider this angle A as theta. So adjacent will be this particular side, that will be 12, and hypotenuse will be this particular side EC, that will be 13. Once we know two sides, the third side can be easily calculated using Pythagoras. Remember, in case of hypotenuse, you are going to add the squares, and any of the remaining two sides is asked, then we have to subtract the squares. And don't forget to take the square root of the final answer. Now, so opposite is missing in this case, so we can easily calculate using Pythagoras. That will be 13 square minus 12 square, and everything under square root. That will come out to be 5. Now we know all three sides. So now sine theta is opposite over hypotenuse, that's 5 over 13, and tan, once we get sine, cosec is easily found out. Simply take the reciprocal, and now we will go to tan. Tan is nothing but sine over cos. You can there are two ways. You can take ratio of sine over cos, or you can simply go by fundamental definition of adjacent and opposite and adjacent. Either way, the answer will come out to be same. Here, since we already know sine theta and cos theta, I will utilize those ratios, and I will cancel this divided by 13 in the numerator and denominator, and the final answer will come out to be 5 by 12. And cot will be exactly the reciprocal of that, which is 12 over 5. Let's go to the next question, 818. If 3 cot A is 4, we are supposed to check the given condition. 3 cot A is 4, cot A is 4 by 3, tan A is 3 by 4, which is opposite over adjacent. I will construct a quick triangle. Opposite should be 3, adjacent should be 4. So I will construct opposite as 3, adjacent as 4. Then the hypotenuse will come out to be 5. You can remember Pythagoras triplet 3, 4, 5, and that is also useful. Once we know all three sides, sine A is opposite over hypotenuse, which is 3 over 5, cosine is 4 over 5, and tan is opposite over adjacent, which is 3 over 5, 3 over 4. Now, we are supposed to check something, and it will have two sides. One is the left hand side, and second one is the right hand side. So we'll evaluate the left hand side separately, we'll evaluate the right hand side separately, and we'll show both are equal. These questions are good because you know immediately, you get the feedback immediately whether you are right or wrong. If you can show these two things equal, then immediately you know that you have got full marks. And if something is wrong, you can fix there right away. So let's concentrate on the left hand side. 1 minus tan square A upon 1 plus tan square A. We have tan A ready. We'll substitute the value and we'll simplify the ratio. That will come out to be 7 upon 25. Now let's concentrate on the RHS side. That will be cos square A minus sin square A. That will be 4 by 5. From where I'm getting these numbers? We have already evaluated sine, cosine and tangent, and we have kept them ready. That will be useful. So now the right hand side also comes out to be 7 over 25. So since both sides are equal, we can say LHS equal to RHS, hence proved. Let's go to the next question, 819. In triangle ABC, right angle at B, tan A is 1 over root 3. Find the value of, well, here you don't even have to construct a triangle because this comes out to be one of the standard values. Remember when we studied the trigonometric ratios of the standard angles with the help of a table, we studied 0 degree, 30 degree, 45 degree, 60 degree and 90 degree. This happens to be one of those values. In fact, tan of 30 degrees is 1 over root 3. So just by inspection, we can say that A is actually 30 degree. We don't have to even construct a triangle. The triangle construction is for weird values, non-standard values which don't belong to the table, belonging to Pythagoras triplet and so on. But here 1 over root 3 is actually standard value, which gives us conclusion that A itself is 30 degrees. Once we know that A is 30 degree, well, we can calculate this one, but then we can calculate sine of 30, which is half, and cosine of 30 is root 3 by 2. Similarly, sine C, which is the other angle, they will simply flip and that will come out to be exactly opposite. So now sine A cos C will simply substitute and we will evaluate the value, and second one also, it's a matter of substitution. That will be once we evaluate cos of A and C, sine of A and C, then we have those values ready. Let's go to the next question. In PQR, right angle at Q, PR and QR is 25 and PQ is 5. So let's see how we can solve this one. Determine the values of sine P, cos P and tan P. Well, let's construct a triangle, right angle triangle, PQR, right angled at Q. If you mix that one, then everything will be wrong. So you have to be careful at what point we are supposed to show the 90 degree angle. Now PR plus QR is 25. So PR plus QR is 25 and PQ is 5. So, and this is X and this is 25 minus X because their total is supposed to be 25. So now we know that this is a right angle triangle. So Pythagoras theorem should be valid. So 5 square, which is this side, X square, which is this side, and that will come out to be 25 minus x, the whole bracket square. Phi square is 25, x square is x square, and 25 minus x, the whole bracket square. We will use the formula of a minus b, the whole bracket square, that is first term square, last term square, and minus twice of their product. Well, x square will get cancelled from both sides, and you'll get like a simplified equation 50x equal to 100. That should give you x as 12. Once you get the value of x as 12, the other side is 25 minus x, which is 25 minus 12. That will come out to be 30. And that should be your answer. Once we know all three sides, then we can find out sine, cosine, tangent of any side. So that will come out to be, first we have to identify which one is opposite, which is adjacent, and which is hypotenuse. Hypotenuse is same for everybody. As far as angle P is concerned, QR is opposite, PQ is adjacent, and PR is hypotenuse. So sine P is opposite over hypotenuse. That will come out to be 12 over 13, and cosine P will be adjacent over hypotenuse. That will come out to be 5 over 13. And tan, well, tan you have options. You can take a ratio of these two individual ratios. That's one method. Or second, just go by the fundamental definition, opposite over adjacent. That will come out to be 12 over 5. If you take the ratio of this one and this one, this by 13 will get cancelled, and you will get 12 by 5 anyway, which is what we have got. So it doesn't matter how you evaluate tan, even by taking the ratio of sine and cos, or that's one way, or second, go by the opposite or adjacent standard trigonometric definition. In both methods, you will get the same answer. Let's go to the next question. State whether the following are true or false. Justify your answer. The value of tan A is always less than 1. Well, this is technically this is true for sine and cosine, but this is not true for tan. There is no such restriction for tangent trigonometric ratio. Remember, tangent is simply ratio of sine and cosine. Since cosine can be 0, you can have a situation 1 over 0, and that's exactly happens in case of 90 degrees. As far as 90 degrees is concerned, tan of 90 will be sine of 90 divided by cosine of 90. That will come out to be 1 over 0, and that goes infinity. So there is no such restriction on tan. This statement is true for sine and cosine. This is false for tangent. Second one. I have shown some random example. Tan 60, you can see it's root 3. Root 3 is approximately 1.73. So that is definitely greater than 1. So this proves that the first is false. Second one, sec A 12 over 5. Remember, cos, sine and cos are less than 1. So sec and cosec have to be greater than 1. These are reciprocal ratio. So they will be always greater than 1. 12 by 5 is actually greater than 1. Greater than 1. So this is actually 2.4 if you evaluate it. So this is possible. Or you can say, like, if sec is 12 over 5, cosine is reciprocal of that, which is 5 over 12, which is definitely less than 1. So that means it's possible. Cos A is abbreviation for cosecant. That's wrong. For cosecant, we use cosec, and cos is actually cosine. Those two are different things. Cot A is a product of cot and A. Technically, that's also wrong. Cot A is one single trigonometric ratio. These are not multiplication. It's not like cot is separate value and A is separate value. Cot A is a single parameter and single value, and that is a one trigonometric ratio. So this is false. Sin theta is 4 by 3 for some. Well, 4 by 3 is greater than 1. Sine cannot be greater than 1. The most it can go is up to 1 in the case of 90 degree. So this is highly impossible. So this is false. Let's go to the next question. Tan A plus B is root 3 and tan A minus B is 1 over root 3. Now these two are from the standard table. Remember, root 3 and 1 over root 3. They belong to the table. So this is simpler than what you think. Tan of A plus B is root 3. That means A plus B must be 60 degrees, because for 60 degrees tan is root 3. So for this purpose, the table must be very, very, very familiar to you. You should immediately recognize that this belongs to this particular angle. Root 3, as far as tan is concerned, that is for 60. So a plus b must be 60, then only tan 60 will be root 3. So this, whatever you see in the bracket, that must be that must be 60 degrees. Let's repeat that process for the second one. Tan of a minus b. Now 1 over root 3 is the tan for 30 degrees. So that means whatever is in the bracket, that must be 30 degrees. So that means a minus b should be 30 degrees. Now we have a plus b value ready, a minus b value ready. This is two equations, linear equations, and that too, one is positive, one is negative. Simply add them. Minus b will cancel with plus b, and you will have only 2a. That will come out to be 90 degrees. A will come out to be 90 by 2, which is 45 degrees. Substitute that in any one of the equation. That will give you 15 degrees as the value for b. So 45 and 15 is 60. 45 minus 15, that will be 30. You can, if you want to be 100% sure, let's take these values, plug them back in the original equation, check whether both equations are satisfied with those values, and if they do, then you can be 100% assured that you have got the correct answer. So this is your final answer. Let's go to the next question. State whether the following true is false, true or false, justify your answer. Sin a plus b is not sin a plus sin b. It doesn't work that way. In fact, when you go to the next standard, in grade 11, you will have compound and allied angles, and then it's actually sin a cos b plus cos a sin b, and it's more complicated than this one. You cannot open the bracket and distribute the sine ratio to individual value. That's not possible. And this is false for sine, this is false for cosine, this is false for tangent, this is false for any for a trigonometric ratio. It doesn't work that way. Always false. And if you want to be 100% sure, check that. Put 30 and 60, so this will become sine 90. Sine 90 is 1, which is not equal to sine 30 and sine 60 added together. The value of sine theta increases as theta increases. You can check that sine 0 is 0. Eventually sine 90 becomes 1. It increases as theta increases. This is true for the first quadrant angle between when theta is between 0 degrees and 90 degrees. Eventually it decreases, but that's not in your syllabus. So this is true. The second one is true as far as first quadrant is concerned. From 0 degrees to 90 degrees, yes, the value of sine theta increases, not linearly. It changes sinusoidally, which is kind of non-linear, but it increases. That's true. The value of cosine theta increases as theta increases. That's not true. In fact, cosine decreases as theta. You can again refer to the standard trigonometric ratio. Cosine 0 is 1, and eventually it becomes cosine 90 as 0, so that means it decreases. Sin theta equal to, well, I have shown that. Sin theta equal to cos theta for all values of theta. That's not true. This is particularly true for 45 degrees. For all other angles, this is highly wrong. So if they are saying all values, that's not true. We can say that this is false. However, if they say sin theta equal to cos theta for 45 degrees, then you have to say it's true. Only for 45 degrees, sine and cosine will be equal. Cot A is not defined for A equal to 0 degrees. Well, cot is a reciprocal of tan. Tan 0 is 0. So cot A is 1 over 0. That's not defined. Division by 0 is not allowed. It's undefined. So this is true. Let's go to the next question. Express the trigonometric ratios sine, sec, and tan in terms of cot. This looks like a weird question, a very challenging, difficult question, but it's not. If you know the fundamental identities, remember the three fundamental identities are sine square theta plus cos square theta equal to 1. 1 plus tan square theta is equal to sec square theta, and 1 plus cot square theta is equal to cosec square theta. So now let's have this sine, cosine, and tangent. Sine is reciprocal with cosec, cos is reciprocal with sec, and tan is reciprocal with cot. So everything, these three trigonometric ratios have to be expressed in terms of cot. Well, tan can be expressed as cot very easily because tan and cot are simply reciprocal. We don't even have to manipulate or do anything. We can simply say tan is equal to 1 over cot. So one thing got taken care of. Now, uh, now let's go to the second one. Sine A is 1 over cosec A. Now, cosec can be written as square root of cosec square A, and cosec can be written as 1 plus cot square A. So sine A is 1 over the root 1 plus cot square A. Remember, the question was express sine, sec and tan in terms of cot. Now, the last one is the second one is the sec A. 1 plus tan square is equal to sec square A, 1 upon 1 plus 1 upon cot square. Remember, this tan square A can be written as 1 over cot whole bracket square A, and then so that means you can manipulate this thing. 1 plus cot square A upon cot square A is equal to sec square A. So that means sec A is square root of everything. Now square root of denominator will become simply cot A, and square root of numerator will be under root 1 plus cot square A. Let's go to the next question. Choose the correct option, justify your choice. 9 sec square A minus 9 tan square A. Well, the first one is easy. You take the 9 common, and then you will have sec square A minus tan square A. Sec square A minus tan square A is simply 1 because 1 plus tan square is equal to sec square. So that means uh, sec square minus tan square is simply 1. So this whole bracket is just 1. 9 times 1 will be 9. So your correct option will be option B. Now second one, 1 plus tan theta plus sec theta, that's one bracket, and second bracket is 1 plus cot theta minus cosec theta. Let's try to make them in terms of sine and cosine. So we'll have something common denominator, and let's see whether it goes somewhere. Here the common denominator will be cos theta, here the common denominator will be sine theta. So now it will be cos theta plus sine theta as it is, and 1 as it is. Here the common denominator is sine theta, then sine theta, and then cos theta and minus 1 as it is. Now sine theta cos theta will be common multiplied denominator, and then this will be think this as a plus b, and think this as a minus b. So it will be a square minus b square. So now this will become cos square theta sine square theta 2 cos theta sine theta minus 1. However, cos square theta plus sine square theta is equal to 1. That will cancel with this minus 1, and then you will have 1 minus 1 got rid of, and then eventually you will have 2 sine theta cos theta upon sine theta cos theta, and then after cancellation the final answer will come out to be just 2. You have to be careful about these kind of questions. They are not really complicated, but if you don't have the basic grasp over uh, the basic three trigonometric ratios, reciprocal three trigonometric ratios, and the identities. If you are comfortable with them, then these questions can be solved easily. Again, choose the correct option. You have been given two brackets. One is sec A plus tan A, and the second one is 1 minus sine A. Well, let's convert everything into the basic trigonometric ratio, sine, cosine, and tangent. Sec is the reciprocal of 1 over cos, tan is the sine over cos. So you'll have some common denominator, which is cosine, and you'll have numerator as 1 plus sine A. Now you'll have 1 minus sine A as the second bracket. So it will think about as a plus b and a minus b. So it will be a square minus b square. So that is exactly what I have written here, 1 minus sine square a. But 1 minus sine square is cosine square. So that is one cosine will get cancelled, and only one single cosine will remain, and that's your answer. The next question is 1 plus tan square a upon 1 plus cot square a. That will become 1 plus tan square is equal to sec square, 1 plus cot square is equal to cosec square. Now let's write them in terms of, remember these are reciprocal trigonometric ratios. Let's write them into the basic one. So sec square is 1 over cos square, cosec square is 1 over sine square. Remember, if you have cos here, that means you will not get cos here, and if you don't have cos here, then you will get cos here. It's kind of weird, but that's the way you can remember it. Then it will be sine square upon cos square, which is tan square. So that will be your final answer. Now, this concludes our chapter 8. Let's proceed with chapter 9, which is application of trigonometry. This is also called heights and distances. Trigonometry is widely used for measurement of distances and angles and heights. Uh, and the basic thing which you have to remember is angle of elevation and angle of depression. Well, if you stand and look directly straight, this is your line of sight, uh, horizontal line with reference to your eyesight. And then if you uh, now, sometimes they mention the height of the person, then you have to subtract that one because that means uh, the measurement is not with reference to ground, the measurement is this thing with reference to eyesight. If they don't mention, then assume that the height of the person is negligible, the eyesight is same as the ground level. Sometimes they do, sometimes they don't. So you have to be a little bit careful. We'll see some problems, and sometimes they have mentioned the height of the person. Most likely, if the height of the person is given, then you have to subtract from the overall distance. Otherwise, assume at the ground level. Now, if the person is raising his neck and eyesight level is the new eyesight level is at the higher elevation compared to the original one, then this will be referred as angle of elevation. As opposed to that, in the second one, uh, if he's standing on the top of the tower or top of the mountain and he's looking downwards, then this is called angle of depression. So uh, if you make mistakes here, and then your triangles will be wrong, and then your calculations will be kind of messed up. A circus artist is climbing 20-meter long rope. Remember the fundamental ratios, sine, cosine, tangent, and their definitions, whether they are opposite or adjacent, opposite or hypotenuse, adjacent or hypotenuse. Now, in these kind of questions, I have realized that if you can understand, interpret what is given, the actual calculations are not really like time consuming or this thing. It's just a matter of like whether you can understand what they are trying to tell you. The first step in these kind of questions is to construct a diagram. If your diagram is correct and according to the given instructions, given parameters, given information, then half the question is solved right there. If the diagram is wrong, then you'll keep on doing unnecessary things and your answer is guaranteed to be wrong. Now, a circus artist is climbing 20-meter long rope. Okay, now, so the rope is assumed to be diagonal. Now, which is tightly stretched and tied from a top of a vertical pole. So you have to be careful about these keywords: vertical, horizontal, incline, and all those things. Here, the pole is vertical, so that means the pole which I have shown with the pink color, that is actually vertical, and the top of that pole is connected with the ground, so this is inclined, so this is the rope. Now, in this case, we have to find out the height of the pole. So whatever is this pink line, that is the pole, and that height is not known. The rope is known, so hypotenuse is known. So now this is particular angle 30 degrees, and in this case, one thing is known, one thing is unknown. So you have to find out which trigonometric ratio is useful. In this particular situation, for this 30-degree, opposite is unknown, but we are interested. Hypotenuse is known. So now we are trying to connect opposite, which is what we are interested in, to the known parameter, which is hypotenuse. What about adjacent? Well, we don't care, and it's not asked, so just forget about it. So this question is about connection between opposite and hypotenuse. Which trigonometric ratio connects opposite with hypotenuse? That would be sine. So that is the reason I have used sine. Now, this is one of the rare situations where sine ratio is used. Most of the times, tan ratio is used because inclined things are not really required. If you are flying a kite, if you are tying a rope, if the aeroplane is taking off, these are the very rare situations where inclined distance actually comes into picture. But most of the times, remember my words, most of the times horizontal distance, which is in terms of how much distance you walked, how long is the shadow, that's one thing, and what is the vertical thing, which is the building, tower, and all those things. So most of the times you will be connecting, correlating opposite with adjacent. So most of the times you will be using tan ratio. This is one of the rare situations. Why sine is used? Because in this case, hypotenuse is given. Most of the times hypotenuse is not given. This is one of the rare situations. So just remember that for a while. So in this one, we are trying to connect opposite with hypotenuse. The trigonometric ratio which connects opposite with hypotenuse, will go back to the fundamental definitions. Sine ratio is opposite over hypotenuse. So that is the reason we are considering sine. If opposite and adjacent was involved, we would have used tan ratio. If adjacent and hypotenuse was involved, then we would have used cosine ratio. So the second most important thing in this one is to identify, after drawing the right triangle, given the information marked on that triangle, the second most important thing is to identify which trigonometric ratio you are going to use. In this case, we are going to use sine, and that will be sine is opposite over hypotenuse. Opposite is the pole, which we don't know, but we want to find out, and hypotenuse is 20, which we know. So it's the matter of sine 30 is, we already know it is half. From where we got that information? Remember the standard trigonometric ratio, which we studied at the beginning of the lecture. If you have missed that somehow, go back to the start of this video and check. In the first couple of minutes I have discussed, and you can use the standard trigonometric table given in the textbook also. So it's a matter of cross multiplication. This by 20 will go there and becomes multiplied by 20. So the opposite will be 10. So height of the vertical pole is 10. Units are important, meters. And that would be your final answer. A tree breaks due to storm. Again, this is very peculiar solution situation. We have a tree which was upright. This is before, and something happened and it broke somewhere in the middle. Not exactly in the middle, somewhere in the from top to bottom it broke, and it bent into two separate pieces. So now this was original tree, it bent this dotted line, and this upper portion kind of touched the ground after bending. So it became like this one, and the bent portion is making 30-degree angle with this one. So if you draw this triangle, if you understand what is given, then half the question is solved right there. So for this tree, the unbroken part is still the opposite side for this 30 degrees. This is the longest side, because remember, longest side is the right angle is right here. So directly facing that one, which is opposite side. Hypotenuse is directly facing 90 degree. That's one way. Or hypotenuse is the longest side always in any right angle triangle. So the remaining one is adjacent. So now tan 30. So here, what we want to find out? We want to find out height of the tree. So we care about this opposite, and we know the tan 30 is 1 over root 3. Now your question will be, why tan is used, why not sine like the previous question? Here touches the ground is 8 meter. So this distance is given as 8. I should have written here somewhere. The distance between the foot of the tree, which is this point, and where the top touches the ground, which is this point, this distance has been given 8. So opposite is unknown, x, and adjacent is known. So we are trying to correlate opposite and adjacent. So we will get tan ratio. So now we'll have step 1 as tan, which is x is 8 over root 3. And remember, if we want to calculate the total height of the tree, so just x is not enough. We also should get hypotenuse. So x value is 8 over root 3, and this hypotenuse can be found out by, well, now we have multiple options. You can use Pythagoras theorem, and you can say like this square plus this square and under square root. You can totally bypass trigonometry in the second step if you absolutely hate trigonometry. Any two sides are sufficient to find out the third side in a right angle triangle. So in step 2, trigonometry ratio is not used. Trigonometric ratio, even if it is not used, you will still get the answer from Pythagoras theorem. Ultimately, you have to remember that the original tree is actually total of this distance plus this distance. So that will be, you have to add them. So whatever distance you have got, x and r, you have to add them, rationalize them, and then you will get 8 root 3 as the final answer. A contractor plans to install 2 slides. Well, You can go through the description. One slide is for the smaller kids below 5 years, and another one is kind of little bit grown up kids, that is above 5 years. So now for smaller kids, you want to keep things simple and nice and smooth, um, within controlled limits. So he keeps the angle as 30 degrees. For grown up, they are more willing to take risk. They can climb more distance, so he increases the angle because they probably will not play with smaller slide. So he has a contractor has two separate slides. One has angle 30 degree and one has angle 60 degree. And in this case, the opposite is 1.5. In this case, opposite is 3, and we are supposed to find out the length of the slide. Now here is one of the rare cases again, because we are interested in diagonal distance, which is the hypotenuse. So most likely here tan will not be used. Remember my previous words. Tan is used when you use the vertical and horizontal, which is most of the times. But here we also we use the inclined distance, so most likely it will involve either cosine or sine. Let's see what does that mean. So in this case, we are trying to correlate opposite with hypotenuse. So we'll use sine ratio. Sine of 30 degrees is half, which is 0.5, by the way. You can write 1 by 2 or you can write 0.5, either way. And then this will be, you can exchange this hypotenuse with 0.5. Hypotenuse will be 1.5 divided by 0.5. Dividing by 0.5 is multiplying by 2, so that will come out to be 3. In the second one, we will repeat this process, but instead of taking 30 degree, now we will take 60 degrees. So that will come out to be the root 3 by 2. Sine of 60 degrees is root 3 by 2. So that will hypotenuse will give you 2 root 3. So we have two slides. One is 3 meters and another one is 2 root 3 meters. Let's go to the next question. The angle of elevation of the top. Well, these are the questions where you have to be careful about angle of elevation and angle of depression. So let's quickly draw a diagram. Angle of elevation. So person is somewhere here and he is raising his eyesight level. So top of the tower. So this must be a tower, and this is the shadow. So he is standing 30 meters from the foot of the tower, and the angle of elevation is 30. Well, he looks at the top of the tower, the angle of elevation. He raises his eyesight level, and that will be 30 degrees. So now we know the adjacent, which is 30. Why? Because the person is standing 30 meters away from the foot of the tower. So this adjacent is completely known. And we are interested in opposite, which is the edge. So we don't know the height of the tower, so that will be edge. So we are trying to correlate opposite with the adjacent, and that will be that would be 30 tan ratio. Tan is opposite over adjacent. So this will be h divided by 30, opposite over adjacent. Tan of 30 is 1 over root 3, so h by 30 is 1 over root 3. Now we can do the cross multiplication, rationalization, and our final answer will come out to be 10 root 3. A kite is flying at a height of 60 meters above the ground. So let's see, the kite is somewhere here. This is the string, the person is standing here. The kite is at 60 meters from the ground. So the vertical distance, elevation is 60 meters. We are supposed to find out string, which is the hypotenuse, this particular one. So for this 60 degree, this is opposite, this is hypotenuse. We are trying to correlate opposite with hypotenuse. So we'll use the sine trigonometric ratio. Adjacent, we are not even interested. So sine 60 is opposite over hypotenuse. So that will come out to be sine 60 from this trigonometric ratio. It is root 3 by 2. And string hypotenuse is, I have kept it as string. So string goes on the other side and do some manipulation. String goes on the other side, root 3 by 2 comes this side. So it will become 60 divided by root 3. Dividing by fraction is same as multiplying by its reciprocal. So it will come out to be 120 by root 3. Even though technically this answer is correct, we prefer to use a rational number. This root 3 is an irrational. How can we make it rational? Well, by the process of rationalization. We will multiply both numerators and denominator by root 3. In that process, this will become 3, this will become 120 root 3. And then 120 can be cancelled with 3, that will have 40 root 3 meters. A 1.5 meter tall boy standing at some distance, the angle of elevation increases from 30 degree to 60 degree. So that means there are two angle of elevation. That means there will be two right angle triangles. That means there will be two equations and you will have to solve two unknowns and eventually you will get the answer. So there is some common methodology in these kind of questions. We have done problems up to now as single right angle, which has only one right angle triangle. But I think from this point onwards, we will have two right angle triangles with two angle of elevations or two angle of depressions, or even interesting, one angle of elevation and one angle of depression. That is also possible. So let's see. So let's try to draw a figure. 1.5 meter tall, and that's the reason I have shown a small extended line, because even though the complete distance is this much, the eyesight level starts from here. So now uh, the building is 30 meters tall and 1.5 meter tall boy. Uh, so this is 1.5 and this complete distance is 30 meter, and we will have to subtract because the height of the person is given. Now the angle is 30 degrees here, and this angle, when he walks towards the tower, the angle of elevation increases from 30 to 60 degrees. So we have two right angle triangles here, right? So in the first right angle triangle, well, in both right angle triangle, the tower height from the eyesight onwards, it is 28.5. From where I am getting 28.5, the total complete distance is 30, but the eyesight level is 1.5 because the height of the person. Now you'll say like, oh, the eye level is not exactly height. That's technically you are right. The forehead distance and the height, the above the eyesight level is neglected. You don't have to be 100% accurate in that case. Some people will always find out that conceptual mistakes. They are right. There is nothing wrong in that. So this distance is 28.5. Now this is x, and this is the distance he has walked. Now we are supposed to find out how much distance he has walked. So we are not interested in adjacent. We are actually interested in the difference of these. So that's like how much distance he walked. This becomes critical because now there is no direct formula for how much distance he walked. So now we have to consider the right angle triangle twice. So I normally prefer with the smaller triangle first because that involves less variables. It depends, but most of the times we should start with the simpler triangle. So let us consider this right angle triangle. In this case, you will say, oh, wait a minute, walk is here. It's not. We will find out this x first, then we will find out x plus walk, and then we will manipulate, remove the x from that. This is how we are going to do, because there is no trigonometric ratio for this obtuse angle. Trigonometric ratio at this level, they are only defined for right angle triangle, at least for your level. So there is no relation which we can use for this triangle. It is not a right angle triangle. So everything must be based on the right angle triangle. So first we'll start with the smaller triangle, right angle triangle, and in this case we are trying to correlate opposite with adjacent. So that will be tan of 60 will be opposite over adjacent. So tan 60 is root 3 from the standard trigonometric table, and we will get x value as this thing. Okay. So that's one part. Now we are going to forget that smaller triangle. We are going to consider the bigger triangle, and we are going to repeat that process. Only thing is now we will be using 30 degree as the angle. For 30 degrees, this is the opposite, and the adjacent is no longer just this x. The adjacent is complete x plus walk distance. So now tan of 30 is opposite over adjacent, and that will be tan 30 is 1 over root 3. That will be 28.5 divided by x plus walk. Because now when you're considering bigger triangle, the adjacent is not just this x adjacent, the adjacent is complete x plus walk as the adjacent. So now that entire distance x plus walk will be going here. And now x distance we have already found out. We'll substitute that and we'll try to cross multiply, get something on this side, and then we'll try to find out the walk distance. So moral of the story is like two right angle triangles will be involved because there is no trigonometric ratio definition for obtuse or acute angle. So everything must be based on the right angle triangle. In that process, you will encounter, come across two right angle triangles. That means you will have to write down trigonometric ratio for a smaller triangle, trigonometric ratio for bigger triangle, and manipulate the values, get something from there even though it is not required. Now think about it. I didn't really want this x, but I got it anyway because this x was really required in the subsequent case. So some people will say like, why x was calculated? Our ultimate objective was work. But we cannot find out walk directly. We have to calculate x first, and this x has to be removed from the next answer such that we will get the walk distance. So if you understand how it works now, these are pretty straightforward questions, no twisted questions, and I believe that in the exam they will ask something based on this one. They will not go for something really complicated. So now let's go to the next question. From a point on the ground, angles of elevation uh, from the top of the transmission are fixed at the top of the building. So there is a building, and on top of the building again there is a transmission tower. So let's see how it works. So this is the building and this is the transmission tower. Transmission tower is normally on the top of the building. You might have seen them in your area because they want like larger coverage. So this mobile towers, anything related to transmission is preferred to be at a higher distance. So this line up to here, that will be building, and on top of that there will be a transmission tower. Now a person is standing somewhere here. He looks at the bottom of the transmission tower, which is nothing but top of the building. Top of the building is same as bottom of the transmission tower, and then top of the transmission tower. So he get two angle of elevations, and one angle is 45 degrees, one angle is 60 degrees, and so this is the building, this is the tower, this angle is 45 and this angle is 60. So let's see. Also we have been given the high 20-meter high building. So that means the height of the building has been given as 20 and the tower is unknown. Let's call it as x. Now this is exactly what we did, but now instead of like think about like the previous question, rotated by 90 degrees. Same methodology. There is no trigonometric ratio for this smaller triangle because it's not right angle triangle. So we'll go from, we will encounter two right angle triangles, we'll come across two trigonometric ratios and then we will manipulate. First I will go for the smaller trigonometric ratios. Now this is opposite, this is adjacent. Adjacent technically is not required, but it will be eventually required to get the value of x. As far as the smaller triangle is considered, for 45 this is opposite and adjacent. So tan 45 is always 1. So if you do that, adjacent will also come out to be 20. Now we will forget about the smaller triangle. We will go for the bigger triangle. So bigger triangle, tan of 60, which is now we have to consider the entire triangle, and that will be again opposite over adjacent. But now opposite is not just 20. Opposite for the bigger triangle is 20 plus x, the complete distance, 20 plus x. So I will write down the equation. Tan 60 is root 3 from the standard trigonometric table. Opposite is the complete distance, 20 plus x, including building and the tower. So that will be 20 plus x. And adjacent is still same. Adjacent we have actually calculated. Remember, now this is where these previous calculations are coming into picture. Whatever you have calculated, 20 meters, that is now useful because we can now plug in that in the next equation and we can get this answer. So 20 plus x by cross multiplication, 20 root 3, and then we can subtraction. Now if they have not asked like final decimal answer, even this answer is correct, there is nothing wrong. If they have specifically mentioned root 3 is 1.732 approximately, it's an irrational number, so then we have to proceed further. So I have shown both because technically if they have not mentioned utilize root 3 as 1.732, then you can stop right here, but let's go ahead and assume that they have given the value. And if you are not sure, go all the way up to this particular thing, then you can be 100% sure that there will be no deduction of marks. Let's go to the next question. A statue, 1.6 meter tall. Now this statue, building, tower are always 90 degrees except the Leaning Tower of Pisa, which is in Italy, I guess. Everything is like standing vertical, right? So statue 1.6 meter tall, so this must be statue. Oh, on the top of a pedestal, so we have a pedestal, and on top of pedestal we have a statue. So this is pedestal and this is the statue. Okay, so again the person is standing somewhere far away from the statue, including pedestal, and its angle of elevation is 45 degrees, and then it eventually becomes 60 degrees when he looks at the top of the statue. So he can look at the bottom of the statue, which is top of pedestal by the way, and the top of the statue. So that's how you are getting, he is getting two angles of elevation. One is 45 degree, one is 60 degree. So again same methodology. Let's say this is y, this is, the only difference is in the previous case I think this value was and this was unknown. Here the statue is, and then we'll find out. Let's see. First we'll consider the smaller triangle, opposite over adjacent, tan, which is 45 degrees. We'll get y over x as 1, so y is same as x. And the second triangle, which is the bigger triangle, tan 60 will be opposite over adjacent. So that will be, now opposite is 1.6 plus y, and adjacent is still x. So remember, x and y is still same, so x can be replaced by y. Remember here, in the first step you have got y and x are identical, so I have replaced this x by y, and then when you cross multiply this one, this root 3 will be multiplied by x, which is by the way same as y. So root 3y is 1.6 plus y. Now we can combine these things, take them on one side, and we can calculate the value of y. And if you want, you can rationalize this one, that will be a good idea, and then you will get the correct answer. The angle of elevation from the top of the building to foot of the tower. Oh, okay, now this is kind of crazy. We are standing on the top of a building and foot of the tower. Now, is the building taller or tower taller? Again, there can be confusion. Let's see how it works. This is the ground level, and these are two buildings. Now, you are standing on the top of the building. So you are standing here, and you are looking at the bottom of the tower. Now, you will say, how do you know that building is smaller and tower is bigger? Yes, there can be confusion. Generally, tower is bigger, but as far as this problem is concerned, this person is standing on the top of the building, and then he's looking at the bottom of the tower and the top of the tower. One is angle of elevation, and another one is angle of this thing. So let's see how it works. Okay, so from here the angle of elevation is, from here the angle of elevation is 30, and here the angle of elevation is 60. Now this angle is bigger, so that means the tower is bigger. That's one way of recognizing it. I know people can get confused, like which one is bigger, which one is smaller. It depends upon which angle is bigger. If the angle of elevation is bigger, that means the construction which is related to that higher angle of elevation must be taller. That's one way of recognizing it. First we'll consider this triangle, and we'll say opposite in this case is 50, adjacent is x, tan 60 is root 3, so 50 over x. So x is this one. Now this we will utilize for the second triangle. Again, here it doesn't matter whichever angle you take first. There is no smaller and bigger for this one. In any case, whatever information you are getting from the step 1, which is the first triangle, you must utilize that for the step 2, which is the second triangle. So the order doesn't matter here. Tan 30 is 1 by root 3, opposite over adjacent. Opposite is h, small h, lowercase h, and tower was uppercase h. So again you cross multiply, then here there is no need of rationalization. Numbers root 3 multiply as 3, and the height comes out to be 16.67. Two poles are equal heights. Okay, two poles of equal heights. Well, there is no confusion. Standing opposite to each other, and the road is 80 meters wide from a point between them on the road. Now, somebody is standing in between of them. So, is he standing exactly in the middle? Well, that's kind of dangerous assumption. It's not clearly mentioned whether the person is exactly standing in the middle. The whole road, the entire road is 80 meters wide, that's for sure. From a point between them on the road, not necessarily midpoint, the angle of elevation of the top of the pole is 60 and 30 degrees. Well, had he imagine, hypothetically, if he was in the middle, then these two angles were same. But these two angles are unequal. That means the person is kind of shifted on one side. So let's assume that the total distance is 80, which is given, 80 meters wide. Entire road is 80 meters wide, and one side angle is 30, one side angle is 60. So now, so let's assume that one side is x. So other side will become 80 minus x. And these two buildings are, these two poles are exactly identical heights. So h and h. On this side, we will say take tan 30 is equal to opposite over adjacent. That will become 1 over root 3 h, which is opposite, x is adjacent, and x will be root 3 h. And as far as second triangle is considered, we will repeat this process. Tan 60, tan 60 is root 3, and then adjacent is 80 minus x, opposite is h. So now we'll cross multiply, we'll get, substitute the value of x. So that is the whole idea. We'll get two triangles, so we'll get two relations, and first relation somehow we have to substitute in the second one. So that will come out to be 80 root 3 minus 3h equal to h. Then after multiplication and cancellation, it will become h is equal to 20 root 3 meters. Now they have not asked you only the height of pole. Well, they have asked you the height of the pole, that's one. So if you leave it here, you will not get complete mark, because they have also asked the distances of the point from the pole. So not only they have asked h, which you have calculated here, they have also asked you the distance from pole number 1 and pole number 2, which are unequal. So you must calculate the value of x, and then this is one answer. And the second will be 80 minus x. So that's another answer. A TV tower. Well, TV tower stands vertically. That's good. On the bank of a canal. So from a point on the other bank directly opposite, the angle of top is 60. Another may, from another point 20 meter away from the point of the line, this angle of okay. Let's see the diagram and let's try to make sense of it. A TV tower. Well, this is the TV tower. It's vertical, and height we don't know. So h. From a point on the other bank. Okay, so let's say this is the other side. So this is the canal. Angle of elevation is 60 degrees. So this is 60 degrees. Now the person walks 20 meter away, and angle of elevation becomes 30 degrees. So this is the TV tower directly on one side of the bank of the river or canal, and other side of the river gives you 60 degree angle. Now the person walks further 20 meter further away from this thing, and then he makes 30 degree angle, because now he is far away, so the angle actually decreases. So what is the height of the tower and width of the canal? Well, okay, first we'll always start with the smaller triangle. That's always recommended. For this smaller triangle, for 60 degrees, this is opposite and this is adjacent. What about the hypotenuse? It's not asked, we don't even care. It doesn't. So that's the reason we are not using sine and cosine here. We use tan. So when vertical distances and shadows, vertical distances and horizontal work are involved, most of the times you will use tan. I want you to go back to all these questions and find out how many times you have used sine, cosine, and how many times you have used tan. In heights and distances, most of the time you use tan. We use sine or cosine when hypotenuse is involved. That is very rare in case of ladder, in case of rope, kite, aeroplane taking off, and all those things. A tree breaking down, those kind of questions. So remember these things. So for the smaller triangle, tan 60 is root 3, which is opposite over adjacent, and that will give you first relation. Now we'll forget about the small triangle. Let's consider the bigger triangle. Now, as far as this 30 degrees is concerned, this is still the opposite, but now the adjacent has increased. It will include x and 20 both. So that will become tan 30 is equal to opposite over adjacent. Tan 30 is 1 over root 3. Opposite is still h, but adjacent is x plus 20. So that will, after cross multiplication, we should get the value of x. Remember, x and h both are in be required. So h is actually root 3x, which is root 3 times 12. That will come out to be 10 root 3 meters. Let's go to next question. From the top of 7-meter high building. So there is a building 7-meter tall. Angle of elevation is cable tower. So h. So this is a cable tower, and this is 60 degrees from the top of a building, angle of elevation. So person is standing here, he looks at the top of the cable tower. So this angle is 60 degrees, and he looks at the bottom of the cable tower, angle of depression is 45. So he looks up 60, he looks down 45. He's standing here and he's looking once here and then once here. So once angle of elevation. So it's not necessary that both will be angle of elevation, both will be angle of depression. This is a scenario because once he is raising his eyesight level and once he is looking at the bottom, so one angle will be angle of elevation, another angle will be angle of depression. So I'm going to draw this like twice because I want to keep it like simple. So let's draw this dotted line, and this 7 will be again replace 7 because opposite side of the rectangle. So and this will be h minus 7. So now we will consider this smaller triangle. Let's assume that this distance is x. So as far as this 45 is concerned, this is opposite, this is adjacent. So tan 45 is the best thing that can happen because tan 45 is just 1. So you can say x is equal to 7. Now consider the upper triangle. In upper triangle, tan 60 is opposite over adjacent. Opposite is h minus 7. Why it is h minus 7? Because this is 7, so this is also 7. If this complete thing is h, then this is h minus 7. Now root 3 is equal to h minus 7 upon 7. So we'll calculate this one and then we'll get the value. Let's go to question 13 and observe from the top of lighthouse 75 meters high. So this is the ground, this is the lighthouse, 75 meters, and this is most likely the opposite side, 30 degrees. Now angle of depression of two ships. Okay, so this is ship 1, this is ship 2, and the person is standing somewhere here at the top of a 75 meter high. So now this is his line of sight. He is lowering his eyesight level. So first angle of depression is 30, second angle of depression is 45. So once we get this diagram correct, then everything becomes a little bit easy. So first we are going to consider the smaller triangle. So for smaller triangle, now why this is 45 and this is 45? Alternate interior angle, because these two are parallel lines. Line of sight is supposed to be parallel with the ground, horizontal distance, so the horizontal level. So I am assuming that this and this are identical. Now, if the smaller triangle is considered, then this will be for 45, this is opposite and this is adjacent. So you can write down tan 45, best thing that can happen, tan 45 is just 1. So you can say that 75 and x2 are identical. This information we will have to use for the second time. So now consider the bigger triangle. This is also 30, alternate interior angle, and tan 30 will be opposite over adjacent. Opposite is 75, adjacent is x plus x1 plus x2. Now complete distance is not known, half distance is not known, partial distance is not known. So I'm going to assume that this is x1 and x2. So x2 is already calculated. Let's plug in that as 75, and then x1 is also known. So now x1 75 times root 3 minus 1. Find the distance between the two ships. Ship 1 is here, ship 2 is here. The distance between two ships is x1, and that has been 75 times root 3 minus 1. That will be your final answer. Let's go to question 14. A 1.2 meter tall girl. Here the height of the person is given. Most likely we will have to subtract. Let's see the question. Spots a balloon. So this is the balloon somewhere here, and I have taken as 87, where they have given 88.2. Well, I will subtract 1.2 meters. That will come out to be 87. So a balloon is here, the girl is here, she raises her eyesight level and it becomes 60 degree angle of elevation. After some time, the balloon is traveling, let's say towards right, horizontally without gaining or losing altitude. and now it is, so this is the original position of the balloon before, and this is the final position of the balloon after, and let's assume that it travels in the same line because uh, they have not given that it is going upwards or downwards, so I'm assuming that it remains at the same horizontal level. So now this 87 remains 87, and now the girl is still there, and she looks at the other position, which is the top of this particular line, and now the angle of elevation is 30 degree because the balloon is farther from her. So again, it's the same thing, x1 and x2. Consider the smaller triangle first. Tan 60 is opposite over adjacent. Opposite is 87, directly facing in front of it. Adjacent is x1. So x1 will come out to be 87 by root 3, which after rationalization gives 29 root 3. Let's consider now the bigger triangle. Tan 30 is opposite over adjacent. Now opposite is still 87, but the adjacent is x1 plus x2, comprehensive, complete, total together. So I have written x1 plus x2. So now cross multiplication, and x1 is already found out. We'll subtract that, x2 comes out to be 58 root 3. What is asked here? Distance traveled by the balloon. The distance traveled between this and this dotted line, which is same as x2. And that will be 58 root 3. And the units will be meters. A straight highway leads to foot of the tower. This is a little bit tricky question. Uh, let me show you what is happening here. This is the road, okay, straight highway. It leads to the foot of the tower. So eventually, if you don't do anything, you will land at the foot of the tower. This is the tower, assuming to be vertical. And a car initially is here, okay. So now there is a car here, right, and a man standing at the top of the tower. Since this is the tower, this is the top of the tower, so the man is standing here. He looks at the car, the initial position of the car, and final position of the car. Remember, the car is approaching towards the foot of the tower. So when he looks at, in the beginning, the angle of the eyesight connection is like this one. After some time, the car comes closer to the tower, and then the same person, the eyesight connection becomes like this one, and eventually the car will reach the tower. Now this is given as, this is line of sight. So originally the angle of depression, which is lowering the eyesight, remember he is at the higher elevation, so he has to lower his eyesight level. So this is 30 degrees and this is 60 degrees. So let's complete the rectangle. We are supposed to find out the time taken by the car to reach to the foot of the tower. So let's assume that this distance is x1, this distance as x2. They may not be necessarily same, and alternate interior angle. So this, if this is 60, this is also 60. Now consider the smaller triangle first. For this 60 degree, this is opposite, this is adjacent. So we have to use the tan ratio. And again, this 30, same alternate interior angle. So let's consider the smaller triangle first. Tan 60 is opposite over adjacent. Tan 60 is root 3. Opposite is h, we don't know, height of the tower. Adjacent, that also we don't know, x2. So all we can do is like come up with a relation, which eventually we'll substitute, and let's do something. Now we'll consider the bigger triangle. For bigger triangle, this is opposite over adjacent, 1 over root 3. Tan 30 is 1 over root 3, and we'll use the second equation. We have already found out the relation between h and x2 that we will use, and still there are two unknowns, so people get stuck right here. What can we do? Remember, they have not asked you what is the distance x1 or x2. They have asked you how much time it will take. So now the car travels x1 in 6 seconds. Okay, this is the information which we have not used still, so that can be helpful. If the car travels x distance in 6 seconds, so x1 is 6 times v, where v is the velocity. Remember, distance is always velocity multiplied by time. So x1 must be 6 times velocity. Similarly, x2 in t seconds, which we don't know by the way. So x2 is t times velocity. Remember, distance is time when velocity. So now x1 is 6v and x1 is 6v and x2 is tv. where t is time, v is velocity. So we can take v constant and we can eliminate them, we can cancel them out, and only this thing will remain. Now we have to find out t. So cross multiplication, 6 plus t time is equal to root 3 t, which is 3t, and then from we can get t is equal to 3 seconds. So that will. So this was a quick revision. Hopefully you will gain something from this one. You will not forget anything till the time of exam. If you want, you can go to the YouTube channel. Individual problem is solved uh, as a single separate isolated video. If you want more explanation, if you think this is too fast, you can actually go to the channel. There is a playlist made by me for heights and distances, and you can see individual video. There will be 15 videos for 15 questions for chapter 9. That's one option. Or second option is, if you cannot find it, let's go to the website vidyanti.com. It's completely free as of today. Even you don't even require a login and password. Go to the website, click on standard 10, and then go to math, then go to chapter 9 and follow the arrows, and then you will see the videos there. That's another way. You don't even see video advertisement there because these are not hosted on YouTube. So you have two choices. If you cannot understand, if you don't understand anything from this video, a particular question, and if you want to see that more elaborately explained, then go to the individual video, either from YouTube playlist or from the Vidyanti website. If you like this video, please comment. That helps the algorithm, spreads it to more people. We have incidences where somebody writes a comment and the video becomes, it's considered popular, and then YouTube recommends it to more and more people, and that promotes it kind of super fast. So it will be a nice thing if you comment it. Write good thing, bad thing about us. That will give us feedback. Share with your friends. You can directly use the share link in the YouTube. And if you are not subscribed, subscribe. That helps us boost our confidence. If you would like to know more about my credentials, blah blah blah, you can pause the video and see who am I. This is Professor Prashant More or Prashant Sir, recording live for Vidyanti.com. Our website is www.vidyanti.com. Wish you all the best. Hopefully, I will be making video for other chapters too, so please stay connected. And if you have subscribed, it will be recommended to you without any difficulty. So, all the best. Thank you very much. See you soon.